In this video, I want to show you how to solve a simple series circuit. In a series circuit, what we have is we have one single loop in which all the resistors or light bulbs or whatever devices are connected within that one loop. Now, in a series circuit, all the currents are the same. So first thing we're going to do is we're going to solve for the total resistance, also known as the equivalent resistance. That is the total resistance seen by the battery. And then through Ohm's law, we're going to get the current supplied by the circuit. Now, to get the equivalent resistance, we have our formula that the equivalent resistance is all the other resistors added together. Here we have two resistors of 2 and 4. So to get the equivalent resistance, we simply add those and get an equivalent resistance of 6 ohms. Now the next thing that we do is we use Ohm's law to solve for the current. Ohm's law says that V equals I times R. And so in this case we have 6 equals blank times 6, and I turns out to be 1 ampere. Again, 6 equals I times 6, and we get I to be 1 ampere. Now in a series circuit, all the currents are the same. Perhaps one way to remember that is the word series has an I in the middle. So all the I's are the same. They are all 1 ampere. And whenever we know 2 out of the 3 values, we're going to solve for the third one using our Ohm's law. Our voltage is going to be 1 times 2. Again, V equals I times R, so 1 times 2, which gives us 2 volts. Here again, we have V equals I times R. We have 1 times 4. We get a voltage of 4 volts. So essentially, we solve for the voltage, the current, and the resistance at all spots of our circuit, the battery, and all devices, whether they be resistors or light bulbs within that circuit. In this next problem, we have a 12-volt battery represented by the 2 parallel lines. A reminder that the long line is the positive terminal and the short line is the negative terminal. And again, we have 2 resistors. We first step to get the equivalent resistance. That's the resistance seen by the battery. And we do so by adding all the other resistors together. 6 plus 4, and that gives us 10. Our next step is to use Ohm's law to get the current. Ohm's law says V equals I times R. Here in the battery, we have the voltage is 12, solving for I, and R is 10. That gives us a current of 1.2 amperes. Now remember, in a series circuit, all of the currents, all of the I's are the same. Therefore, all of the currents are 1.2 amperes. Once we know 2 out of the 3 values, we solve for the third using Ohm's law. So here we have the current as 1.2. We have our resistance as 6. And that gives us a voltage of 7.2 volts. Same thing here. We have our current as 1.2. Our resistance is 4. And that gives us a voltage of 4.8 volts. In this next circuit, we have a 24-volt battery connected to 2 resistors, 10 and 8. What I'd like you to do is I'd like you to go through and first solve for the equivalent resistance and the current at the battery. So pause the video, solve for those 2 things, then unpause and see how well you did. All right, welcome back. What you should have found was that the equivalent resistance is 10 plus 8, which gives us 18 ohms. Using Ohm's law, V equals I times R. we have that 24 is equal to I times 18, and this gives us then a current of 1.33 ohms. I'm sorry, amperes. 1.33 amperes. Now what I'd like you to do is I'd like to solve for the voltage and the current at the two resistors. So pause the video, solve for those, and when you're ready, unpause and see how well you did. In a series circuit, all of the currents are the same. So we have a current of 1.33. That is the current in all sections of the circuit. Then we can get the voltage by multiplying the current and the resistance. Here we get the voltage to be 13.3 volts. Here we get the voltage to be 10.7 volts. In this last problem, what I'd like you to do is solve the entire thing. Solve for the voltage, current, resistance at the battery in each resistor, and then when you're ready, unpause the video and see how well you did. Alright, in our first step here, we're going to solve for the equivalent resistance. We're going to take 3 plus 5, which gives us 8. Then we're going to solve for the current using Ohm's law. We have 10 is equal to I times 8. And we get the current to be 1.25 amperes. All the currents are the same in a series circuit. So they are all 1.25 amperes. Once we know two values, we can solve for the third using Ohm's law. Here we get the voltage at the first resistor to be 3.75 volts. And we get the voltage at the second resistor. Comes out to be 6.25 volts. The process is always the same. Solve for the equivalent resistance, then solve for the current using Ohm's law, and all the currents are the same in the series circuit.